Hello and thank you for joining this presentation. Today, I will be presenting our study title, Pilot Scale Deep Oxygenation for Hypoxia Mitigation and Water Quality Improvement in Sungai Klang, Malaysia. Sungai Klang is one of the most urbanized and polluted rivers in Malaysia. Decades of untreated wastewater discharge, stormwater runoff, and sediment accumulation have contributed to hypoxic condition where dissolved oxygen levels falls below 2 mg per liter. This condition lead to habitat degradation, fish kills, and challenges in water treatment processes. Addressing this requires not only pollution reduction but also in-stream oxygenation strategies. This pilot study investigates the use of deep oxygenation technology using fine bubble diffusers. Our objective is to evaluate its effectiveness in improving oxygen levels and reducing pollutants in hypoxic water extracted from Sungai Klang. We focus on key water quality indicators including dissolved oxygen, biological oxygen demand, chemical oxygen demand, nutrients, total suspended solid, trace metals such as manganese and iron. We constructed a pilot-scale plume model tank or PMT using hypoxic water directly sourced from Sungai Klang. The tank was fitted with submerged fine bubble diffusers which release pure oxygen at the bottom. This design ensures minimal mixing while maximal vertical oxygen transfer through buoyancy-driven plume motion. No mechanical agitation or stirring was used. This allowed us to isolate the effect of oxygenation alone. Sampling was carried out at a fixed interval over 3 to 5 days. Grab samples were collected at various depths and parameters were analyzed using Lovibond MD600 for multi-parameter photometric analysis and TB211IR for turbidity. We analyzed dissolved oxygen, BOD5, COD, total suspended solids, ammonium, nitrate, manganese, and iron. Within the first 24 hours, dissolved oxygen levels increased from less than 1 mg per liter to around 4.5 mg per liter. By day 3, dissolved oxygen levels exceeded 7 mg per liter, surpassing the minimum threshold for healthy aquatic ecosystems. This demonstrated the high oxygen transfer efficiency of the submerged diffusers, even in static water conditions without mixing. Biochemical oxygen demand or BOD5 dropped by over 50%, indicating effective biological oxidation of organic matter. Similarly, chemical oxygen demand level decreased, reflecting a reduction in total oxidable substances. Ammonium concentrations decline while nitrate increases. Evidence of nitrification which requires sufficient oxygen. This shows that deep oxygenation supports essential microbial processes for nutrient transformation. Manganese and iron concentrations drop significantly after 48 hours. This suggests oxidation of dissolved metals into insoluble form followed by precipitation. Total suspended solids also decline moderately, likely due to a flocculation and settling, although no sediment removal step was included. In conclusion, deep oxygenation via fine bubble diffusers is a viable intervention for hypoxia in rivers like Sungai Klang. It enhances dissolved oxygen, reduces organic load, transforms nutrients, and facilitates metal oxidation, all without aggressive mixing. These pilot data support the feasibility of scaling up the approach for use in river restoration and pre-treatment application.